Okay, so for this question 31, given that you are a rational function 3 over x squared minus 4, then they say x cannot be negative 2, x cannot be negative 2 and 2, then logic lah, because denominator cannot be 0 what, so this value cannot be 0, so this is the part for this rational function. This is the vertical asymptote part. So they give you a composite function fgx is equal to this. Obtain gx where gx is a positive function. Then state is domain. Okay, so they are testing us on composite function here. So first of all, they say fgx equals to 3 over x minus 5. Then we are going to substitute our gx where our gx is not given, so we will take the whole gx. We're taking the whole gx, substitute inside to our function fx. So substitute this gx into the function fx, it will become 3 over gx squared. Okay, so from here we can simplify our function in order to find out what is our gx. So 3 can be simplified. When I move the 3 to the right hand side, it will divide by 3. So now I will have gx squared minus 4 equals to x minus 5. So we have to find out what is our gx. Move the 4 to the right hand side, it will be plus 4. So our gx function here is equals to x minus 1. So when you want to move our square, it will become positive negative of this function. Okay, when we want to move our square, it becomes square root, it will become positive and negative answer. So from the questions, question say that our gx function is always positive. So therefore we can do our conclusions here. Since the function gx is always positive, therefore we can conclude out our function gx is a positive surd function. So from here we get our gx and then state its domain. So when we want to state its domains, we have to refer our function gx here, where our function gx here is a surd function. So for the surd function, it is our special case, DSLR. So surd function for our domain is a special case. How we find out the domain? We will take what is under the surd. X minus 1 should be greater than equals 0. So x greater equals to 1. So therefore, the domain of gx is equals to x greater equals to 1. Either we can write it in inequality form, or we can write it in this interval form 1 to infinity. So from here we can see they are testing us on composite function. How we do our composite function. This is our first concept. Then try to solve until we get gx and justify our answer where our gx is a positive function, so you will ignore the negative answer. So although it do have positive and negative, because of the question it said positive function, therefore this negative part we will reject, we will ignore it. So this is our final answer. Then go for the domain part. So this is our straight answer. Domain is x greater equals to 1. Okay, continue for question B. Show that G inverse is axis. So if we want to know that inverse axis or not, we have to find it, is it is a one-to-one function. So from here we can test it by using algebraic method. where we perform the calculation, we show that G inverse is axis. So start from the function gx, we know that just now we found it. Gx is equal to x square root x minus 1. So in order to do the one-to-one function algebraically, we will start our assumption here where gx1 will equals to gx2. So therefore, we will try to substitute x1 into the function. So for left hand side, it will become square root x1 minus 1. For right hand side, we will substitute the x2 into the function. It will become x2 minus 1. Then we will get to a third equation. So for third equation, how we going to simplify it? We will do square both sides as topic 2 we learned it. Then we manage to simplify equals to x minus 1, here equals to x2 minus 1. So we have to find out what is our x minus 1. When our x minus 1, we move the 1 to the right hand side. So you'll notice that x1 leaving the answer equals to x2. So when we get x1 is equals to the answer of x2, from here we can show that this function gx is 1 to 1. Therefore, our G inverse will be axis. Then, after show that G inverse is axis, hence we're going to find what is the function of G inverse and state out its domain. Okay. So in order to start with inverse function, we'll do G inverse x equals to y, and then gy equals to x. Substitute y into the function here, it will be square root y minus 1. Okay, so we have to simplify. Find the y. Once you find the y, means you found the G inverse. So how we solve this square root? We will move to the right hand side here. It will become square. Then we move the 1, it becomes plus 1. So we get our y. So that will be our G inverse. So from this G inverse, x squared equals to 1, it is a quadratic function. So it says state the domain. When you want to state the domain of G inverse, although it is a quadratic function, it is not special case. Quadratic function, the domain will be infinity, negative infinity to infinity. It's not special case. But because this inverse function is come from gx, means that I have to refer back to our gx here. So domain G inverse, it should be referring to range of the function gx. So what is the range of this function gx? So we can read here what's the range for this function gx. So for the range, for the third function in answering range, it will be our special case where we will close the third here. We can see 0 out here, nothing is there, so 0 to infinity. So range will be 0 to infinity. Okay, what is our concept here? The first one, our algebraic concept showing this function is 1 to 1. Then we can get G inverse. Then we solving our G inverse, finding its answer of function G inverse. Lastly, we state out what is the domain of G inverse by referring to the function of by referring to the original function gx. Okay, so for question C, what they ask us to do here, they say please find the value of AB if function hx is ax plus b such that h composite with G inverse will equals to 5x squared plus 12. So we start with the composite function that they give us here. So h G inverse composite answer is 5x squared plus 12. So we follow the composite, we will substitute our G inverse here. So just now our G inverse is x squared plus 1. So this is what you're mapping. You are mapping x squared plus 1 using function h. Alright, so but now I want to simplify to function mapping of x only. I don't want mapping of x squared plus 1. I want to mapping of x only. So when you want to find of this single term, you have to use, this is like two terms here in the mapping, right? So we want to find back the single terms in the mapping, we have to use let. We let m equals to x squared plus 1. So we change this function in terms of m. So when I want to find out what is our x, it will be m minus 1 and then square root. Oh, so I doesn't need x, I just need x squared only. Enough. I can substitute already. So by using this, I can get hm. So now you can see when I let this x squared plus 1 into a single term here, it become m. My mapping of the function is hm. So in a single term, it is equivalent to x. So for x squared plus 1, it is doesn't same with hx. They are not same. They are not mapping in the same things. Alright, so that's why when I see in the bracket the mapping domain here, I have to let it to be a single term. Then for the x squared part here, we change it to the m. For x squared, it will equal to m minus 1. So I simplify here, hm equals to 5m minus 5. So 5m plus 7. So therefore, I can mapping back to the single x from m to the single x. So I compare to the question they give us, they say hx is equal to ax plus b. What I get here is hx equals to 5x plus 7. So from here I can compare that coefficient of x where a is equals to 5. Then the constant at the back here, b, is equals to 7. So what is important marks here, you have to tick down. So the first one is how we going to see you use the composite function here. Alright, and then we can simplify. Or if you don't want to use this method, I have another method to show you. Alright, so I show you another method where if you don't want to let it become m, because you already got hx, right? So I can substitute the x squared into the hx here. So I gave you another method to see here, where hx squared will become ax squared plus 1 equals to 5x squared plus 12. Okay, so I will substitute the x squared plus 1 into the place of x. So here will become ax squared plus 1 equals to 5x squared plus 12. Then when I plus, wait, I'm missing a b here. Okay, so we're going to expand, it will become ax squared plus a plus b equals to 5x squared plus 7. So from here, I also can do the comparison where quadratic a is equals to 5. Then a plus b is equals to 12, where a is 5. You substitute, so b can equals to 7. So I have two alternative ways to do this. Whether I going to find out what is my hx, then I compare my hx, or I second method here, I finish up the comparison and then I compare the answer of 5x squared. So both come to the same concept. Okay, first is doing your concept of composite, and then if you're using this, this is your answer, and then you compare, and then you get your B. This is your answer. How you do your this is how you do your answer, and then you get your comparison of coefficient to get answer AB. So that is the method. Another method here is how we find out our function of hx, and then still same comparison to get AB.